to 1, then r gets 1, else, okay, we need it may not be easily done with factorial. Oh, I think I can do it. I can do it. Okay, we can do it like this. N gets n minus 1. Invoke factorial. And then we say n gets n plus 1 again. R gets r times n. And if n define sub. Okay, obviously in this case, indentation can be quite useful. So let's go ahead and add some indentations here, just so that we can see what this program is really doing. Increase indent. And the outside code, or the code that is outside of the definition of the subroutine, is going to be quite easy. All we have to do is to define what n is. Let's just say we want to find a factorial of 3. And then we invoke the subroutine. Okay. What is so special about this program? That is,
it's a recursive program.
It is a recursive program, and the definition of a recursive program is, or the recursive subroutine, is the subroutine will eventually invoke itself. Okay, we're invoking the factorial inside of factorial. Is that confusing?
Yes.
It is confusing only because you guys are thinking too hard. Okay? Now let me just re-emphasize that, because it is the case. This looks mysterious only because you are thinking too hard, which is a good thing. I really like the fact that you guys are thinking and trying to understand all this stuff, but you feel that this is difficult only because you're thinking too hard. The two things that we have talked about when you invoke a subroutine, what are the 3 things that we do? We allocate a column, we remember where to continue execution, and then we continue execution in the subroutine that we are supposed to invoke. Right? What do we do when we're at the end of a subroutine? 2 things. One is to look up the last return line number column, or the most recently created return line number column. We look up where we're supposed to go back to, or where to continue execution, and then we deallocate that column, right? Because those things are something that we have consistently done in this class up to this point. We are not changing those rules, even in this case. We are using exactly the same rules to do exactly the same thing, even when it looks kind of strange that we are invoking a subroutine from within itself. When I first took programming the first time, and I was introduced into recursive subroutines, I was just completely baffled. Okay, I was thinking, how can you invoke a subroutine when the subroutine is not even done being defined? That was in my mind when I was looking at the subroutine, which turned out to be an incorrect thing, because guess what? The subroutine is entirely defined at this point already. So let's go ahead and just take a look at this algorithm, and if we have time, I will even explain why factorial is such an important thing that we will basically use factorial again and again as an example. First thing to do is to remember to save the file. So even if I forget to upload, it is here at least. So we'll use factorial as an example throughout the discussion of subroutines. In other words, as we introduce local variables, parameters, and so on and so forth, we will continue to come back and revise factorial so that we can use all those newer concepts to make things a lot easier. Okay, so this is kind of like the find max algorithm that we talked about at the beginning of the class, except in this case, it is a slightly different type of algorithm. In this case, we do need one column for comments because we have a conditional statement. We have line number. We have 2 variables to deal with. We have n and r as variables. So we'll go ahead and start with these 4 columns initially. Okay. That's good. The precondition is we don't need to care about the value of either variables because they will be overwritten properly in the right order. What is the first line I should execute in this case? What is the first line out that is outside of any subroutine definition?
12.
Line 12, okay, not counting the empty line. Line 12 is going to say, okay, we'll start the value of n with 3. Okay, no big deal. We know how to do that. Line 13 is invoking a factorial subroutine. Remember what I said? We're not changing the way we do things at all. So what do? We allocate a new column, which is column E. We label it as return line number so we know what that column is used for. And then what do we do? What do we specify as this column? Post, because there's nothing else to do after that. And then we continue execution in the subroutine being invoked. So that means we have to continue execution on line 2. Very good. Okay, so see, easy stuff. Nothing that is different so far. And I think R needs to be a little bit wider and can be narrower. What does line 2 do? Well, line 2 doesn't really do much. It is just evaluating a comparison. N is less than or equal to 1 is false. Okay, so where do we go next? So we go to line 5. Very good. Line 5 doesn't really do much except to decrement the value of n by 1. N is 3, it becomes 2. Then we go to line 6. Line 6 says we want to invoke factorial. Oh, my goodness. What am I supposed to do now? We're invoking a subroutine inside itself. But is that any more special than the other invoke statements that we have seen so far? Nope. It's the same way. What are the three things we have to do? Allocate a new column. What is the column? What is the next column I can use?
F.
Column F. Very good. So we allocate that column. We label it return line number. Which line am I supposed to go back to?
7.
Line 7. And then what do?
Go to line 2.
We go to the first line of the subroutine that we're invoking. And that would be?
Line 2.
That would be line 2, right? All right. So we haven't done anything differently so far. Okay? What does line 2 do again? Oh, line 2 is going to compare. Okay, is n less than or equal to 1? Nope, it is false. And then what do we do? Go to line 5, right? What does line 5 do? Decrement the value of n, so it goes from 2 to 1. Then what do? We go to line 6, right? Line 6. And what do we do when we invoke a subroutine? Same old stuff, right? Isn't that nice to be boring?
Yeah.
Because we're doing the same thing again and again and again. It looks kind of strange, but guess what? We are still doing the same old 3 things all over again. Allocate a new column, this time column G. Label it return line number. Remember where we're supposed to continue execution after the subroutine is done? Where?
7.
Line 7, the following line. Okay, so nothing has changed. And then we continue execution on the first line of the subroutine being invoked, which is line 2. All right. Man, that is boring. Okay, so n is less than or equal to 1 is true. Finally. And then we can execute line 3 instead of line 5, which is good because line 3 is really short. What does line 3 do? R gets 1. Okay, just like that. And what do we do after line 3?
Line 7.
Nope.
8.
Nope. Come on. We're inside the conditional statement. When we're done with a branch of a conditional statement, we're done with the entire conditional statement.
And if.
Okay? But we don't execute and if. We go to the line following the and if. So what line number are we talking about?
10.
Line 10. Very good. Okay, so what do we do on line 10? It is at the end of a subroutine. We look up the most recently created column with a return line number label. Which column are we talking about here?
G.
Column G. Very good. So we look up column G, and column G says we are supposed to go back to line 7 to continue execution. Okay, we'll go back to line 7. And then we'll go ahead and deallocate column G because it has been utilized. Are we okay so far? Is this any different from the previous two examples?
No.
Not in the least bit, right? Okay, very good. What do we do on line 7? Line 7 is kind of boring stuff we do in this class. Adding 1 to n, okay, so n goes from 1 back to 2. We go to line 8. Line 8 says we want to multiply r to n, so 2 times 1 is 2. We store the result back into r. R gets updated to 2. And then what do we do after line 8? Line 10, very good. And what does line 10 do again? We look up the most recently defined return line number. Should we use column G again?
No.
No, because it's already marked freed or deallocated. So a column that is deallocated cannot be used anymore because it does not really have a value that can be used at this point. So which column should I use to look up where? Column F, very good. So column F is telling me that we have to continue execution on line 7, and then after I utilize the value of that column, I deallocate that column. It is no longer in use at this point, and now I'm back to line 7. What does line 7 do? Add 1 to n. N goes from 2 to 3. Then we move on to line 8. Line 8 wants to compute the product of, okay, well, in this case, it may be helpful to do this. Line 8 wants to compute the product of, it wants to compute the product of n and r. N has a value of 3, r has a value of 2. 3 times 2 is 6. We store the result back into r, so r is now updated to 6. And after line 8, we go to line 10 directly. The last line, or the most recently created line with the return line number, is now column E. Column E tells us to continue execution at post. So we say, okay, we'll go back to post, and then we deallocate the column that told us to go back to post. And once we are at post, there's nothing else to do. We're all done. Yep.
When it goes through the inner loops, basically,
But there's no loop. That's the beauty of recursion. There's no loop here. Even though it seems like we're doing some kind of a loop, there's no loop. Yep. Go ahead.
So, what happens if you were back to line 2 instead of to line 7? Then would it be?
But why would we want to go back to line 2? The return. We go back to line 7 because the invoke is on line 6. Okay? Because whenever you invoke a statement, wherever you are, what you write down to remember on where to continue execution is what line is logically following the invoke statement itself. Right? So because the invoke statement is on line 6, the line that is logically following line 6 in this case is really easy. It's just really literally the next line, which is line 7. But is that any different from the previous two examples that we have already captured in this spreadsheet? The mechanism to invoke has not changed. The mechanism of what we do at the end of a subroutine has not changed. Okay? And that is why I said, initially, when I asked you guys, do you find this confusing and difficult to understand? And you guys said yes. And I said what? You guys were overthinking. Okay? Because if you think in terms of what do I need to do at an invoke, what do I need to do at the end of a subroutine, guess what? That has not changed at all. It is the same boring stuff that we have talked about since the beginning of this class period. Are we doing okay so far? Sort of? No?